The Antikythera Mechanism is an ancient Greek analog computer. It was used for calculating astronomical positions and dates. It was discovered in 1901 off the coast of the Greek island of Antikythera. The mechanism was found among the wreckage of a Roman ship that sank around 60 to 70 BCE. The device is often referred to as the world's first known analog computer. This title is due to its complex system of gears and dials used for precise calculations. The Antikythera mechanism dates back to the 2nd century BCE. Radiocarbon dating and stylistic analysis suggest it was made between 150 and 100 BCE. It consists of at least 30 bronze gears. These gears are intricately designed to perform various astronomical calculations. The mechanism was housed in a wooden case, roughly the size of a shoebox. The dimensions of the case were approximately 34 cm high, 18 cm wide, and 9 cm deep. The front dial of the mechanism shows the zodiac and the Egyptian calendar. This dial allows users to track the positions of the sun and moon against the zodiac signs. The back dials include a Saros cycle and a Metonic cycle. The Saros cycle predicts eclipses, while the Metonic cycle aligns the lunar and solar calendars. The Antikythera mechanism can predict solar and lunar eclipses. It uses a sophisticated gear system to calculate the timing and type of eclipses. It also tracks the movements of the planets. The mechanism includes gears that simulate the orbits of Mercury, Venus, Mars, Jupiter, and Saturn. The device has inscriptions on its surfaces. These inscriptions provide instructions and labels for the various dials and functions. The Antikythera mechanism was likely used by astronomers and astrologers. Its precision and complexity suggest it was a tool for both scientific and religious purposes. It was probably operated by turning a hand crank. The crank would have driven the internal gears, moving the dials to show different astronomical events. The mechanism was lost for over 2,000 years before its discovery. It remained buried in the sea until it was accidentally found by sponge divers. The Antikythera mechanism is considered one of the most important archaeological finds of the 20th century. Its discovery revolutionized our understanding of ancient Greek technology and science. The device was initially dismissed as too advanced to be genuine. Scholars initially struggled to believe that such a complex machine could have been created in antiquity. The Antikythera mechanism was reconstructed using X-ray and CT scans. Advanced imaging techniques allowed researchers to see the internal structure of the corroded remains. The mechanism is now displayed in the National Archaeological Museum in Athens. It is one of the museum's most prized exhibits, attracting visitors from around the world. The Antikythera mechanism is believed to have been built in Rhodes or Corinth. These cities were centers of scientific and technological innovation in the Hellenistic period. It was likely owned by a wealthy individual or institution. The complexity and cost of the mechanism suggest it was not a common item. The Antikythera mechanism could predict the dates of the Olympic Games. The Olympic cycle is integrated into the Metonic cycle, which the mechanism tracks. The device includes a pointer for the position of the sun. This pointer moves along the zodiac dial to show the sun's position throughout the year. The Antikythera mechanism has a pointer for the position of the moon. The moon's pointer also indicates the phase of the moon. It can calculate the synodic month, the time between two full moons. This calculation is crucial for predicting lunar phases and eclipses. The mechanism includes a display for the Callippic cycle. The Callippic cycle is a 76-year period that aligns with the Metonic cycle. The Antikythera mechanism has a display for the Exoligmos cycle. The Exoligmos cycle is a 54-year period that predicts the recurrence of eclipses. The device can indicate the positions of the 5 known planets at the time. These planets are Mercury, Venus, Mars, Jupiter, and Saturn. The Antikythera mechanism is believed to have been part of a larger educational or navigational tool. Its multifunctional design suggests it served multiple purposes beyond just astronomical calculations. The mechanism's gears are made of bronze. Bronze was a common material for durable and corrosion-resistant mechanisms in ancient times. The Antikythera mechanism has a differential gear system. This system allows for the accurate calculation of the difference between the sun and moon's positions. The device can predict the visibility of the planets. It calculates when planets will be visible in the night sky based on their positions relative to the sun. The Antikythera mechanism is thought to have been lost in a shipwreck. The ship carrying the mechanism was likely transporting luxury goods and artworks. The mechanism's complexity rivals that of 18th century clocks. Its intricate design and precision are comparable to those of much later mechanical devices. The Antikythera mechanism has been the subject of numerous scientific studies. Researchers continue to uncover new details about its construction and use. The device was likely used for both practical and ritual purposes. It could have been used to plan agricultural activities, religious festivals, and navigation. The Antikythera mechanism has inspired modern replicas. Engineers and historians have built working models to better understand its functions. The mechanism's gears are arranged in a series of concentric layers. This arrangement allows for compact and efficient operation. The Antikythera mechanism is a testament to the advanced knowledge of ancient Greek astronomy. It demonstrates the Greeks' deep understanding of celestial mechanics. The device was likely designed by a team of skilled engineers and astronomers. The complexity of the mechanism suggests a collaborative effort. The Antikythera mechanism has a complex system of interlocking gears. These gears work together to perform multiple calculations simultaneously. The device can predict the timing of solstices and equinoxes. It tracks the Earth's position relative to the Sun, indicating the changing seasons. The Antikythera mechanism is believed to have been used for horoscopes. Astrologers could use it to determine the positions of celestial bodies at a person's birth. The mechanism has a pointer for the lunar node. The lunar node is the point where the moon's orbit crosses the ecliptic, crucial for eclipse prediction. The Antikythera mechanism can calculate the length of the tropical year. This calculation is essential for creating accurate calendars. The device includes a display for the anomalistic month. The anomalistic month is the time between the moon's closest approaches to Earth. The Antikythera mechanism has a display for the draconitic month. The draconitic month is the time between the moon's passages through the same node. The mechanism can predict the occurrence of planetary stations. Planetary stations are points where a planet appears to stop moving in the sky. The Antikythera mechanism is a rare example of ancient Greek mechanical engineering. Few other artifacts from this period demonstrate such advanced technical skill. The device has a display for the synodic periods of the planets. Synodic periods are the intervals between successive conjunctions of a planet with the Sun. The Antikythera mechanism continues to fascinate scientists and the public alike. Its mysterious origins and advanced capabilities make it a subject of ongoing research and wonder.